For these types of problems, this one's illustrating, it doesn't have to be something going round and round and round in a circle like the previous one, the merry-go-round here. It could be something moving in a curved path for a certain amount of time. Then you'll still have the centrifugal and centripetal forces acting on that object. Now, the other thing we have to be careful of is in this example, the centrifugal force is acting in one direction and gravity is acting in the other. But it can be the case, like for this plane here, determine the maximum constant speed that travel around a vertical curve. So that's the maximum speed the pilot can travel around a vertical curve. So this time we're going to have the centrifugal force, which is acting outwards from the center. The centripetal force has to balance that, has to act inwards, which is going to be kind of the lift provided by this plane, or it's going to provide that centripetal force. Those are acting in the same direction. When this plane is at the bottom of that curve, those are going to be acting in the same direction. Gravity and centrifugal force are going to be in the same direction. Anyway, we're going to have to try and figure out, so it's got a kind of center of rotation or a curvature. The radius of curvature is 800 meters. And we want to figure out what maximum constant speed they can go at if they're going to experience a maximum force of 8 Gs. And so that 1 G is the same as the force you experience due to gravity. So 8 Gs is 8 times that, the lowest point of the maneuver. So find the combined, so it's just making clear we're talking about the combined force due to centrifugal and gravity is going to be 8 times the force due to gravity alone. And then we're going to talk about the pilot weighs 70 kilos, but we don't actually need to know the weight of the pilot to figure this out, because centrifugal force is proportional to mass, and so is the force due to gravity. But let's just do a free body diagram of the little pilot. So this is the pilot sitting in their aeroplane there. And so they are going to have some center of mass somewhere. And the forces are going to go through that center of mass, wherever it happens to be. And we're going to have a couple of primary forces acting on this one. So he's moving, moving at constant speed. And so we're not going to have a tangential force. They're not accelerating this way. So the speed is constant. And so there is no tangential force here. There's only the normal forces. It's going to be due to gravity. And so we'll just call that W. We could call it mg. Let's call it mg, because I think we're going to need to cancel out that m at some point. And so this here is going to be mg. And then you're also going to have a centripetal force. It'll also be acting on the center of gravity. But just to show clearly, we'll just move it down here. And that is going to be the centrifugal force, CF. It's going to be acting down that way. Then what are we going to have? Maybe I'll move these up to the top just so I've got space to put my reactions in. So we're going to have both a... okay, let me just redo that. And so put these here. So we're going to have that one acting in the right direction. Just get rid of that ruler while I'm doing this. So you're going to have an mg acting down on that center of gravity. Then we're also going to have a centrifugal force that's pushing the pilot down into their seat. Then we're going to have a reaction. So the reaction is going to be from the seat onto the person, and that's our centripetal force. It's acting towards the center of the curvature, if you know what I mean. So 800 meters away. So, and what we call this, we'll just call this R. We don't have to worry about friction this time because there is no force acting horizontally this time, whereas last time the centrifugal force was horizontal. This time the centrifugal force is vertical. So what do we know? Now that is completely not to scale, but that's okay. We're not going to use a scale drawing or anything like that. I don't like it anyway though. So let me be nitpicky. I want that reaction is going to be about the same length as the combined vectors for the centrifugal force and the weight. So what do we know? We know that R, so that reaction force is equal to 8 times either the force or the acceleration. It doesn't really matter how you think about it. We're going to think about it as force. So it's going to be 8 times 9.81 times whatever the mass of that person is. Now they've given us that. but let's just leave it general, could be any person and any mass. And so that is going to be equal to 8 times 9.81 times 9.81 is equal to 78.48 times the mass of the person. Okay, so that's what R is equal to. Now, this is this inertial force, and so the reaction must be equal to that. It's equal, it's the opposite direction, but the magnitude of that reaction must be equal to that, equal to the sum of these two things. Oops, sum of this plus this, so the gravity plus the centrifugal force. So we're going to have R is equal to mg plus FCF. So therefore 78.48 is going to be equal to 9.81 times the mass of the pilot plus mass times speed squared over rho. Now I just need to be a bit careful. I think our units are okay though, so we're working meter, yeah, it's all good. We're working with meters per second for our acceleration. This is in meters, so no problems there. So let's see what we can figure out from this. So 78.48, oh, that was 78.48 m is the force, is going to be equal to 9.81 m. Don't know why I didn't put in some values there, plus mass divided by 800 times v squared. What else can we do now? So what we can do now is we can divide the whole thing by mass. We've got mass in each one of these terms. So each section of the equation that's divided by a plus or a minus. So we've got mass in each of those. So we can just divide the whole thing by mass. So therefore we're going to get 78.48. It's going to be equal to 9.81 plus 1 over 800 times v squared. That's fine, we'll just keep it like that. 1 over 800 times the speed squared. Therefore 1 over 800 times speed squared is equal to 78.48 minus 9.81 is equal to 68.67. So therefore the speed is going to be equal to, we're going to do 68.87 divide times 800 times both sides by 800 equals, and then take the square root of that. It's going to be 234 meters per second, which is pretty fast. Although it is 8G they're feeling, so it would be pretty fast. Let's just do a quick check on the sanity of that and figure out what that is in kilometers per hour, which is equal to, so if we do 234 divided by 1,000 to get kilometers per second times 3,600 to get hours, 842 meters per second, Mach 3 almost, Mach 2 or Mach 3. So it's going pretty fast, but it seems reasonable, I suppose. I'm not a pilot, so I don't really know how fast planes go, but it seems, oh, what am I writing? Kilometers per hour. What I'm going to do is Google it and just see. Yeah, I'm talking rubbish. So Mach 1 is about 300 odd meters per second is Mach 1. So that's the speed of sound. And so this is not even above the speed of sound. It's just subsonic flight. So that's reasonable, 842 kilometers per hour. What else did it ask us? Pilot weighs 70 kilograms. Determine the force will exert on. Okay, so we've figured out the speed to get the 8G force. That's the speed there. What it wants to know is what's the actual force if the person weighs 70 kilograms. Well, the force that's pushing down on the seat is just equal and opposite to the reaction. So it is just going to be force on seat, or the magnitude of it anyway, is just equal to R, which is equal to 78.48 times the mass of the person. I think they were 70 kilos, which is correct. So 78.48 times 70. 78.48 times 70, which is 5493 newtons, which is a lot, which is equal to 5.49 kilonewtons, say. So it's half a ton. So that's one heck of a force, 8G. You'd think someone would be able to survive that, but who knows, maybe they've got special suits that help them. So therefore we have max speed, or speed that causes 8G. Let's just check the wording of the question. Yep, so lowest. So max speed for 8G is equal to 842, or let's keep it hard, either one would do actually. It didn't really ask us to change it to kilometers per hour, so I'll just put it in meters per second. It's 234 meters per second for 70 kilogram pilot. Force on the seat would be 5.49 kilonewtons. So you'd have to be pretty strong to survive that. Done.